All right, everyone, so this prompt is called Volcanic Eruption. So remember, this is going to be the theme of our essay. We're going to connect it back to this. So let's just look at our scientific background. Remember, this is kind of what we'll summarize to go into our introduction paragraph. So let's take a look and see if there's any vocabulary we can define and use in this. So it says a first grader just constructed a model of a volcano for his science fair project. His high school brother is taking chemistry and wants to help him plan and carry out an investigation of a volcano erupting. He understands his brother will need to use mathematical reasoning and have an understanding of why he is observing two chemical reactions when the volcano erupts. So there's not a lot of vocabulary in this scientific background, but it does mention chemical reactions. So one thing we can do is we can write down what we know about chemical reactions. We know that there are 5 types. We know that chemical reactions are because of chemical changes. We know that if there's a chemical change, that there's a change in the bonds between atoms. And we also know that if we have a chemical change, that it creates new substances or new chemicals. So we're just kind of jotting down some things that we know about chemical reactions. Now let's take a look at the writing task and what our body paragraphs are going to be about. Remember, we're going to circle the words like construct that tell us to do something. Those can be like our checklist for our essay to say at the end when you're reviewing before you do your final draft, okay, did I include everything that they asked me to? So it says construct an explanation of the 2 chemical reactions involved in making the science fair project. In your essay, be sure to, using document A, balance the equations and explain the law of conservation of matter. Law of conservation of matter is a really big vocabulary word, so is balance. Identify the types of reactions occurring in the volcano and give evidence that a chemical reaction has occurred. Justify your reasoning. Explain the 3 states of matter in the chemical reactions. Determine what the first grader can expect to see when he performs the volcanic reaction. So we have several vocabulary words here that we can use and kind of define. So the law of conservation of matter says that matter cannot be created or destroyed. It can only be rearranged or changed, but you can't make it, you can't destroy it. That's why we balance things, because when something is balanced, it means it has the same number of atoms of each element on both sides. Okay, on both sides. So remember, when you have a chemical reaction, you have your reactants, which are kind of like your ingredients on the left side, and the products that are created are on the right side. So with our types of reactions, we know that there are 5 of them: synthesis, decomposition, single replacement, double replacement, and combustion. And for our evidence that a chemical reaction has occurred, these are the indicators of a chemical reaction. And so they might be something like color change, a precipitate, which is a solid. We might see a gas production, so like bubbles or fizzing. We might see a temperature or energy change. For example, if you mix things together and all of a sudden it gets really hot or it produces light, that would be an energy change. And also if there is an unexpected change in odor or the way it smells, all of these can be indicators that a chemical reaction has occurred. Normally you need at least 2 to really draw that conclusion. And then for our states of matter, remember there are always 3 options. Our states of matter are solid, liquid, or gas, and we could talk about maybe how the atoms are different in those. And then it says determine what the first grader can expect to see when he performs the volcanic reaction. So let's take a look at our documents. So document A gives us the unbalanced equations that are in this reaction with the volcanoes. So remember, we see our states of matter. So the the writing for that was very weird. The S in parentheses means that it is a solid. And an L in parentheses means that it is a liquid, and a G in parentheses means that it's a gas. Now, one thing to keep in mind is if we have a solid, so your equation gets split in half, so you have your reactants on the left side and your products on the right side. When you have a solid as a product, that means it is a precipitate. So you should see something solid that's new now in your container. And if we have a gas as a product, that means we're producing a gas, so we should see either bubbling or fizzing or smoke, something along those lines, okay? Now, because they're unbalanced, one of the things that the prompt asked us to do was balance them, so we're going to need to do that. So I'm going to go ahead and rewrite the equation over here so that we can balance it, and we will take a look at it. So the whole point is that we should have each type of element, so carbon, hydrogen, oxygen, calcium, they should all have the same number on both sides. Now, one thing to remember is when you're looking at a balanced chemical equation, the number that goes here is called a coefficient, and that tells you the number of molecules that are in this equation, or the number of moles, and the small numbers are the subscripts, and those tell you the number of atoms. So for example, that 3 tells me that I have 3 oxygen atoms. So we use our coefficients and our subscripts to actually balance both sides. The subscripts are already locked in place because they're dependent on what chemical reaction it is. Oops, sorry, my computer screen jumped a little bit. And if we look here, what we can see is that we have 4 different elements. We have calcium, carbon, oxygen, and hydrogen. We could list them out as calcium, carbon, oxygen, and hydrogen, but notice we have oxygen in multiple places and hydrogen. So one thing I recommend you doing is keeping your polyatomic ions together. So notice we have CO3 on both sides, so we can treat it as one unit. We also have C2H3O2, which is acetate, on both sides as well, so we can keep that together. So what we'll do is we'll instead list calcium, carbonate, hydrogen, and acetate as their own ions and units. So what we look on the left side, our reactant side, we see that there is 1 calcium, so I put a 1. There is only 1 CO3. If there was more than 1, you'd see parentheses with a subscript like this one on the product side. We have 1 hydrogen and we have 1 acetate ion. On the product side, we have 2 hydrogens right here. We have 1 carbonate, we have 1 calcium, and this subscript 2 outside the parentheses tells me that I have 2 acetate ions. So in order to balance this, we would need it to be the same on both sides. We can see that calcium is the same on both sides, carbonate is the same on both sides, but hydrogen and acetate are not. So what you have to do is you have to put a coefficient on the side that has the smallest number. So our reactant side, the left side, has the smallest amount. I find it right here, and let's put a 2, because then the 2 gets multiplied by our elements. So 2 times 1 gives me 2 hydrogens, and then 2 times this whole ion gives me 2 acetate ions, and now we are balanced. So that means the rest of the coefficients will be a 1, or you can leave them as being blank. So our coefficient should be 1, 2, 1, 1. Now for our second equation, I will go ahead and write that down as well. So we have H2CO3 producing carbon dioxide and water. One thing to note is that you don't have anything that repeats itself on both sides, And so we want to go ahead and list them all as separate elements. So we have hydrogen, carbon, and oxygen. On the reactant side, this 2 tells us that I have 2 hydrogens, 1 carbon, and 3 oxygens. On the product side, I again have 2 hydrogens, 1 carbon, but I have 2 oxygens here and 1 oxygen there for a total of 3. So notice my hydrogens are the same on both sides, my carbons are on the same, and my oxygens are the same. That means this equation is already balanced and my coefficients should all be 1s. So that turned out to be relatively simple. So our coefficients are 1, 1, and 1. Now, if we look at the law of conservation examples, so we notice that the mass that they started with and the mass that they ended with is the same, even though there was a clear change in what happened. The coal was completely burned. We can also see that here, if I start with 30 kilograms of the log and 1 kilogram of oxygen, that's 31 kilograms total. Then afterwards, I end up with 28 kilograms of ashes and 3 kilograms of smoke. That's still 31 kilograms total. So the mass remains the same. For document C, we see the types of reactions. So they give us our names and what they look like. So we know that a synthesis reaction is similar to marriage because you have A and B combined to make AB. Decomposition is similar to divorce. Now, in your essay, you might explain the nickname, but you still need to use its official vocabulary name. Single replacement, remember in class we called that one the home wrecker. Double replacement was wife swap. And combustion reaction was baby mama drama. And that's because it blows up in your face and it produces a lot of fire, a lot of crazy. So we have those types of reactions. What we can use this for is to identify which one is happening here. So notice we have 2 elements or more, and it's producing 2 compounds. So that means that our first equation is going to match our double replacement reaction. So that first equation is a double replacement reaction, whereas this one we have 1 reactant and it splits apart into 2 products. That would be decomposition or divorce. So we can use document C to help us with document A in terms of identifying them. So this one was our first equation, and the decomposition reaction was our second equation. We can see that document D gives us evidence of a chemical reaction. One thing we should see is we should see the precipitate of a solid in reaction number 1, because we have a solid as a product. We should also see gas formation in reaction number 2, since there is a gas as a product. We also see that it says water, and we see right here that we produce water. So that means we should also have this one in reaction number 2. It might actually, in fact, be the gas or the smoke that we see. We don't know about a color change or a change in energy, whether or not it'll be hot or cold based on the data that they've given us. But we do see in document E about the states of matter. We see some indicators or kind of characteristics of them, and we can see what happens to their atoms. So here we see that in a gas, the atoms are spread out, whereas in a solid, the atoms are close together and tightly packed, and a liquid is kind of in the middle. So this is kind of a review of some chemical changes, the law of conservation of matter, and you should be able to identify which documents you're using for each bullet point.